Now let's go through some of the steps for conducting a chi-square one-way goodness of fit test. Remember why we're conducting this test. Right? The idea is we want to compare some claimed distribution about a population with some observed distribution. If we had a population, if we had access to the entire data, say through a census, then we wouldn't actually want to conduct this chi-square one-way goodness of fit test. We wouldn't have to. We could just compare what a person is claiming about the population with the population itself. However, in practice, we often don't have the full population. We just have some sample of that population. That's where we use the chi-square one-way goodness of fit test. Especially in the social sciences, for a lot of the questions we're asking, we don't have access to everyone's religious affiliations or everyone's political views. We use random samples from a population. So before we start the chi-square one-way goodness of fit test, we have a few preliminaries. You should first state the target population, as always. Are you trying to make an inference about students living in Hong Kong, adults in London? What's your target population? Then you should state the parameters of interest. In the chi-square one-way goodness of fit test, we're trying to make inferences about population proportions. And then we should check the required conditions we discussed earlier. The idea that the expected cell counts for each category should be at least 5, not the observed counts, but the expected cell counts. And the idea that this should be entailing an inference, so you should have a random sample from a population. So then we go through the 5 steps. The first step is to state the null and alternative hypotheses in terms of the H subscript 0 and H subscript A, just like before, but we will go through the details in just a moment. Then you want to select a significance level alpha. Then you compute the chi-square test statistic. We will go through a few examples by hand, but in general, people use statistical software. However, I do think it is important that you calculate it just so you understand the mechanics. The mechanics are really quite simple once you go through a few calculations. For step 4, you assume the null is true, as usual, and then you make a decision. You compare the chi-square test statistic with some critical value, or you can compare the probability or p-value with the significance level alpha. And then finally, you can state your conclusion. So let's go through at least these first initial steps. Once you've evaluated the preliminaries, you can state your hypotheses. With the chi-square one-way goodness of fit test, we want to test whether or not there's sufficient evidence to reject a set of claimed proportions in the population for a set of K categories. And these claimed proportions, as we mentioned earlier, we use lowercase a, subscript from 1 to K. So if you have K equals 3 categories, you have A1, A2, and A3. Specifically, our null hypothesis is that the proportions for each category in the population equals the claimed proportions. So P in this particular test refers to proportions in the population. Right? This is as you'd expect, right? So just to be clear, P1 to PK refers to those different claimed those different proportions in the population, and then A1 to AK refers to those claimed proportions in the population. So, intuitively, you can kind of think of the null usually as nothing's going on. So in this kind of test, the nothing going on, the null hypothesis is that this person claiming these proportions in the population, in fact, the population proportions are the same as those. Our alternative hypothesis is simply that one of these values of P is not equal to its corresponding claimed proportion, right? Where P refers to the actual proportions of the population and A refers to the claimed proportions based on our hypothesis. For step 2, we choose a significance level alpha. Again, we will use 0.05 by convention. Again, A is used for p-values, critical values, and so forth. And that alpha is the probability of a type 1 error or false alarm. And those are the first 2 steps. In a moment, we will examine steps 3 and 4 and 5.